Hey, this is Ryan with LearnMetrics Tutoring, and today we're going to be going over our second episode in the static series. It's going to be on vectors and forces. So to start off with, we're going to go straight into example problems. Problem 2.24. A man exerts a 60-pound force F to push a crate onto a truck. That's this guy here. Express F in terms of components using the coordinate system shown. So our coordinates is going to be, we have the x-axis down below here, and then we have the y-axis up here. Y in the coordinate system is referred to as j hat, and x is referred to as I hat. It's just another way of writing in the x direction or in the y direction. You don't have the hats all the time. Sometimes it's just j, sometimes it's just I. So we're supposed to express F in terms of the components using the coordinate system shown. So for part A, I can break this F vector down into two directions. I can break it down into an x direction and into a y direction. Now these are going to be the same length horizontally as this F vector goes horizontally, and the same height. So same height, same length. So this is going to be, the bottom line is going to be, if we draw a similar triangle, we have our F right here, and we have a 20-degree line. Let me actually move this up slightly. We would have the magnitude of F times cosine 20 I. So what this is saying is, that if I take my F vector and I multiply it by cosine of 20, then I'm going to find the length of this red dotted line. Now to find it in the y direction, I'm going to do plus sine 20 j. And I'm actually going to add the hats because I'm used to doing that. And then we just punch in the numbers and we see what the answers are going to be. So if we replace F with 60-pound force, notice the units, they don't tell you that this is pound F. They say 60-pound force, so that, I mean, they kind of tell you, but it's tricky if they don't tell you. Times this guy right here. So the numbers we get are going to be 56.38 I hat plus 20.52 j hat. This is going to be F, and I'm going to add a little arrow over it to signify that it's a vector. They do that by making it bold. It's hard to bold things with print, or with writing, so I'm just going to make an arrow over it. All right, so that's part one. Now part two is going to be to determine, or let's read it. The weight of the crate is 100 pounds, pound force, not pound mass. Determine the magnitude of the sum of the forces exerted by the man and crate's weight. Man's force and the crate's weight. So what this question is asking is, there is a weight force here of 100 pound force. And then we have our blue vector, which is our F, which is going in this direction with that magnitude. With vectors, you can always move them around. So for example, this vector right here was originally contacting the edge of the box. I moved it to the center, and that's okay. You can move the vectors around when you're doing force summation. That's the property of superposition, which means you can add them together. So we're trying to add F and W together, and we want to find the magnitude of it. So the magnitude is going to be this final vector here. I'm just assuming it goes in that direction. I don't know too much about it. We're going to figure out what F plus W is at the start. So we know F is going to be 56.38 I hat plus 20.52 J hat. Now if we look at W, W goes straight down, and it's 100 magnitude. That's going to be plus 0 I hat, because there's no X component, minus 100 J hat, because it's negative. So F plus W is going to be equal to 56.38 I hat minus 79.48 J hat. Now, how do we get from this to the magnitude? Because right now, so our X component is going to be this distance, and our Y component is going to be this distance. Now, in order to find the magnitude, we're trying to find the length of this green arrow. This is a right triangle, so we can just use Pythagorean theorem. So what we do is we say that the magnitude of F plus W, which is how it's notated with this, two kind of absolute value bars, is going to be equal to the square root of 56.38 squared plus 79.48 squared. Now I dropped the negative sign because if I added it, it would just be squared and it would disappear anyway. So because I'm lazy, I didn't add that negative sign in there. So our answer would be 97.4 pound-force. And there's our answer to the first problem. So our second problem is very similar to our first one, except instead of being given an angle here, we're given a triangle. 3, 4, and if you know your Pythagorean theorem, this is 5. This is a help to you. You don't need to solve for theta to solve this problem, and I'll show you why while we go through it. So the missile's engine exerts a 260 kilonewton force. A, express F in terms of components using the coordinate system shown. So this is the same coordinate system as above. I hat is the X direction, J hat is the Y direction. So what I'm going to do is I'm going to do that. So F for part A is going to be equal to the magnitude of F times its directions. So that's going to be our X component and our Y component. Now, what this similar triangle is telling you is that for every 5 steps you take in the force's direction, you're going to take 3 steps vertically. Or for every 5 steps you take in the force's direction, you're going to take 4 steps horizontally. So what that means is that we take the magnitude of F times the amount of steps in the horizontal direction over the amount of steps in the force direction, or fifth. Then we do the same thing with the Y component. The amount of steps, 3, in the vertical direction over the total number of steps in the force direction. So with that, we have 260 kilonewtons times 4/5 I hat plus 3/5 J hat. And our numbers for F is going to be 208 I hat plus 156 J hat kilonewtons. That's the first part of our problem. Now the second part is going to be the same thing as before. Let me erase these guys so it's easier to see. So we're going to have F going in this direction with a magnitude of 260 kilonewtons, or 208 in the X direction, 156 in the J direction. we are going to have a weight force. Oh, actually, this is interesting. This is the mass of the missile. So the mass of the missile is 8,800 kilograms. This is no longer the weight force like it was above because we didn't have to do any conversion. The units are in kilonewtons for force, but we've been given mass. So in order to get a force equals mass times acceleration, which in this case is going to be 8,800 kilograms times 9.81 meters per second squared. So our weight force is going to be 86.33 kilonewtons. That is our weight force. This is a downward force of 86.33 kilonewtons. So our next part is going to be to sum these two force vectors together. So that's going to be part B. So if I put them tail to tail, I'm going to get a vector that ends up being probably something like this. So looking at our force vector, and I'm actually going to rename this W for weight, just to make it a little clearer. So F plus W, we're going to use the same approach as above, is going to be equal to 208 I hat plus 156 J hat plus 0 I hat, because it's completely in the vertical direction, minus 86.33 J hat. So F plus W is going to be equal to 208 I hat plus 69.67 J hat. Now, intuitively, we can check this. This is a missile, and it looks like it's going up. So our J component should be positive, which it is. So that's kind of just an intuition check. Now, in order to find the magnitude of the combined vectors, we need to do the same approach as we just did above. So that's going to be the square root 208 squared 69.67 squared. And that number is going to be 219.36 kilonewtons. And that is your answer for part 2. And this is your answer for part 1. So that's an introduction on how to do force vectors. Your goal is to first decompose them. So we had a, let me just erase this here. We had a single vector that was going in the x and y direction. So we broke it down into its component pieces. Then we can take those components and we can add it to other vector components to combine them together. And then we take the square root using the hypotenuse. So for example, this one here, this would be 208, and this would be 69.67. So to find this length is just the square root of both sides. So that's your first example with vectors. Statics deals with vectors a lot. That'll be the end of this video. If you need any help on the units, or you weren't sure on anything in that regard, look at the units guide that I have in the description. It'll help clear you up. And if you want any more practice problems, you can check out the statics course that I have also in the description. I'll see you tomorrow.